Hi students, in this lecture I am going to discuss problems based on Coulombs law, potential, potential energy, right? So till now the concepts what we have discussed. See question number 4. Let's see what is given. An electric field E bar equal to 3I cap plus 4J cap Newton per coulomb exists in the XY plane. Find the potential at 2, 3 if the potential is 0 at origin. So we have to find potential at this point, 2, 3. Field is given 3I cap plus 4J cap and potential is 0 at origin. Okay. Right. See how we are solving this. So 3I cap plus 4J cap. So first write down given data. E bar equal to 3I cap plus 4J cap. At origin potential 0 and we have to find potential at 2, 3. Right. So we have discussed the relation between potential and field, right? How to calculate potential difference. That is VB minus VA is equal to minus integral E bar dot dr bar. Right. This is taken from A to B. Now just substitute values in this. At B potential we have to calculate. So it is V minus at A. A means it is now taking as origin and their potential is given 0. So it is now 0 equal to minus 3I cap plus 4J cap dot dr bar dxi cap plus dyj cap. That is equal to 3 dx, right? I cap dot I cap 3 dx. That becomes 3x plus 4 dy. That becomes 4y. Now take limits origin to 2, 3, origin to 2, 3. And this is minus. So substitute values in that 3 2s is 6 and 3 4s 12. That is now minus 18 and unit is watt. Right. So E bar given and asking potential. So this is a way of calculating potential. Right. So it is a very simple question. Let us see now next problem. A charge Q is to be divided on two objects. In what ratio the charge should be divided so that force of repulsion between them for a given distance is maximum. See carefully. A charge is given. We have to divide this into two parts. And condition is force of repulsion between them for a given distance is maximum. Right. So this is now based on Coulombs law, and also we have learned maxima and minima, right? Basing on that. See how we are solving it. dividing Q charge into two parts. Let us say Q and remaining is Q minus Q. Q minus Q. Now between these two, force of repulsion. Why repulsion means if this is a Q positive, if this is a positive and this also positive only. So force of repulsion F equal to K into K means 1 by 4 pi epsilon naught K into Q1 Q2 by R square. So condition is given for a given distance. That means R is fixed. Now in this only variable is a small q, right? Only variable is small q. So for what value of a small q, force becomes maximum for a given distance. Then we have to use a concept. It is maxima and minima, right? Differentiating that function with respect to variable and make it equal to 0. Let us see now. In this k constant, r square constant, let us focus now derivative of remaining part. So that is now df by dq equal to 0. That implies we are taking now derivative of q into q minus q. And that should be 0. That should be 0. Then see what we get. Q into Q, that becomes a capital Q, minus Q into Q, Q square, derivative of Q square is 2Q, that is equal to 0. That implies Q equal to Q by 2, right? That means it should be divided into two equal parts, means 1:1, right? Then force of repulsion is maximum. Okay, right. See next one. And this also very easy question. Just have a look. If 16 joule of work has to be done against the electric field to move a charge of 1 coulomb from point P to Q, find the potential difference between these points. I think for this even explanation part also not required, right? See how much work is done? 16 joule. What is now charge? 1 coulomb, right? Find the potential difference. Then what we can write? Right. So it is 16 joules of work is done. Since nothing is mentioned, we are taking, it is taken slowly. Work done by external force. That is converting into delta U, right? And this is given as 16 joule, which is equal to charge into potential difference. And Q value given 1. Therefore, potential difference will be 16 watt. So very simple and direct question. See next problem. Right. This is a previous IIT problem. 1998 given for 2 marks. A charge plus Q is fixed at each of the points x0, 3x0, 5x0 and so on x-axis, and a charge minus Q is fixed at each of the points 2x naught, 4x naught, 6x naught, and so on up to infinity, where x naught is a positive constant. Take the electric potential at a point due to a charge q at a distance r from it to be kq by r. Then the potential at the origin due to the above system of charges is. So we have kept 1, 3, 5, and so on positive charge, 2, 4, 6, and so on negative charge. So at origin, what is now potential because of the system, right? See how we are solving this problem. So potential due to point charge, that is given by, it is a kq by r, right? If a charge is a positive, potential positive, charge is negative, potential is negative, right? Let us make a diagram here. So this is origin. 1, 2, 3, 4, 5, 6. Alternatively, we have kept positive charge and negative charge, right? That's the potential will be potential equal to kq. I'm taking modulus of q outside. K means 1 by 4 pi epsilon naught, and take q also outside. Remaining is now, it is 1 by x naught minus 1 by 2x naught. Why minus means? Because the second one is negative charge. And next one positive charge. So plus 1 by 3x naught minus 1 by 4x naught plus and so on. So take x naught outside, q by 4 pi epsilon naught into x naught, 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 and so on. And if you observe, that is now expansion for, this is now expansion for ln 2, right? I hope you are knowing that. Otherwise, now you can know this. It is now expansion of ln. That means now this is q ln 2 upon 4 pi epsilon naught x naught. That is a final answer, right? So only one thing is here, you should know what is the value of this one. 1 minus 1 by 2 plus 1 by 3 minus 1 by 4. This is the expansion of ln 2, right? Okay. Let us move to the next problem. And this also previous IIT question. It is 1984, given for 2 marks. Read the question carefully. Two equal negative charges minus q are fixed at points 0, minus a and 0, a on y-axis. A positive charge q is released from rest at the point 2a, 0 on the x-axis. The charge q will execute simple harmonic motion about origin, move to the origin and remain at rest, move to infinity, execute oscillatory but not simple harmonic. Right. Let us see how we are going to solve the problem. Condition given two negative charges 0 minus a and 0 a means on y-axis. Other one is minus 2a comma 0 on x-axis. SHM remains at rest at origin, move to infinity, execute oscillatory motion but not harmonic, but not simple harmonic. Right. Right. First of all, draw a diagram for that. Right. Right. Let us do. So two charges. It is 0 comma a and this is 0 comma minus a. Right. Releasing a charged particle and this two are negative, right? Minus q and minus q. And this is a positive charge. And coordinates are 2a comma 0. So first focus like this, released from rest. That means this is a system of three charges having only potential energy released from rest. So system of these three charges having only potential energy. And here during this motion, there is no energy loss. That means definitely this has to come to rest when it reaches a distance, it is minus 2a comma 0. See what we are saying here? When it reaches the point minus 2a comma 0, it has to come to rest because energy is a constant. You can observe because of these two negative charges, on this charge, attractive force is there, which is like this. Net force will be along x-axis, means towards origin. So up to origin, this charge moves with a constant, with increasing speed. I am repeating, up to origin, this charge moves with increasing speed because net force is not zero. On reaching the origin, their speed becomes maximum. And can you guess why speed is maximum? Because by this charge, force is along positive y-axis, and by this charge, force is along negative y-axis, and both are cancelled. So net force equal to 0 means acceleration equal to 0. That means here speed is maximum. Okay. Therefore, now it moves towards, it continues to move along x-axis. But once it enters onto the negative x-axis, force becomes attractive. Means it is now becomes net force is along positive x-axis. That means net force is opposite to velocity. So speed keep on decreases. Therefore, on reaching minus 2a comma 0, velocity becomes 0 according to energy conservation. That means this cannot stop at origin because their speed is maximum. This cannot move up to infinity because that is violating energy principle. Right? Now remaining two options are regarding is it SHM or not. Okay. Now what I'm doing here, let us take at one instant distance equal to x from origin. See force acting because of each charge. See how much? K Q into Q by R square. R square is A square plus X square. That is R square. K into Q1 Q2 by R square. And you can see that direction is now, that force is like this. In the same way by this one. Okay. Suppose angle is here theta, angle is theta. And take cos theta, and cos theta will be it is into x by square root of a square plus x square, means this becomes power 3 by 2, right? Cos theta becomes how much? X by square root of a square plus x square. This becomes how much? 3 by 2. Now take into 2 because due to other charge. This is now net force active. Okay. And you can see this is not proportional to x. Just imagine we are releasing the object from origin. If we release from origin, velocity will be zero. If you slightly displace from origin and leave it, slightly, if you take x value very small compared to a, see here what happens. If you consider, if we are taking x is very small compared to a, then this can be taken as 2k q into q by a cube into x, and I can take here negative sign. I am repeating. Suppose we are displacing, means x is very small. If x is very small compared to a, then x square is very small compared to a square. Then we can neglect x square. Remaining becomes a cube. So it is now 2k q by a cube into x. That means if x is a positive, direction of force is negative, means along negative x. If x is negative, direction of force will be positive. That means this is now satisfying condition for SHM, right? It is of the form F equal to minus a constant into x. This is of the form minus omega square into x. Okay. But in this case, x is not small. It is 2a comma 0, right? That's why it is only oscillatory motion, but not SHM. So it becomes SHM only if x is very small compared to a. Then if they ask what is the time period, then what we can write? Time period is t equal to 2 pi by omega, right? And omega value is known from here, right? This is omega value. 2k by a cube is omega square value. Then we get time period, right? Okay, I hope you got that clarity. Let us see next problem. And this also previous I had a question. See what is given. An alpha particle of energy 5 mega electron volt. What is it? Mega electron volt scattered through 180-degree by a fixed uranium nucleus. The distance of closest approach is of the order of. This is the distance of closest approach is of the order of. See how we are solving this one. Given here alpha particle is moving towards a uranium nucleus. I think Z is 92, right? It is 92. Okay. Let us take Z into E, charge of the nucleus, where Z equal to 92. When it moves towards the nucleus, alpha is having positive charge, nucleus also having positive charge. Because of repulsion, this will stop somewhere. Get the point. and it's a kinetic energy completely converts into electric potential energy. If we assume that there is no energy loss, its a kinetic energy completely converts into electric potential energy. So writing here energy equation, that is 5 mega electron volt, right? Mega means 1 electron volt is 1.6 10 power minus 19 mega 10 power 6. 5 mega electron volt. I am repeating 5 mega electron volt. Okay. That is a converting into potential energy. That is K. K value 1 by, sorry, K value, right? 1 by 4 pi epsilon naught, and its value is 9 10 power 9. I'm taking that value here, 9 10 power 9 charge of alpha particle 2e, charge of nucleus 92e, right, by k into q1 q2 by suppose separation is now d. Let us take when this is a coming to rest, separation equal to d. That is the minimum distance. Okay. Now we have to substitute values in this to calculate d, because remaining all values are known. Okay. And this comes out to be approximately it is a 5.3 10 power minus 12 centimeter. Okay. So of the order means it is 10 power minus 12 centimeter. Okay. So here what we have taken, there is no energy loss. So kinetic energy completely converting into electric potential energy. Okay. Right.